So hi everybody. I'm not sure how much fun is it going to be unless you're really interested in natural language processing. And this is the first disambiguation of this talk. If you're waiting for the talk on neuro-linguistic programming, which is also NLP, you're probably in the wrong room. I'm going to be talking about natural language processing. And the idea of this talk is to introduce some concept of NLP and just some examples that could be useful for your first natural language processing project. Okay, a little bit about me. I am Anna Widiger. I'm a computational linguist. I speak 3 languages most of the time. Originally from Russia. I got my degree from the University of Tübingen. And this XKCD comic is how I was introduced to XKCD. It's about computational linguistics, and it's an ill-defined field, just like NLP. You can think of computational linguistics as some parts of computer science, some fun parts of computer science, and all the headaches of linguistics. Okay. So what this talk is about, I'm going to start with introducing some NLP concepts, mostly as it relates to machine learning, but also some rule-based stuff. The main part of the talk are some examples of processing text, real-life text examples. And those examples would be, you can think of it as recipes. First, as an appetizer, I'll show some NLP pipelines with a tweet. And then as a main course, named entity recognition, an example of a Yelp review. And as a dessert, multilingual topic modeling with a toy example. So all of these examples are on the smallest text possible. So you can see all the fun stuff, but it's easily scalable. And I will end the talk with some takeaways of some do's and don'ts of NLP. Hopefully some of it will be useful for your NLP projects. Okay, show of hands. How many of you have done something with NLP already? Oh, wow, that's great. So chances are you know more about it than me because I've only tried some of the things. And another disappointment of the talk is probably going to be I'm not going to talk about deep learning other than introducing some of the concepts because my opinion is for your first NLP project, deep learning is probably a little bit too complicated, unless you already know a lot about deep learning. All right, so let's start with NLP and machine learning. Linguists like to think of languages as living organisms, ever evolving. For data scientists, unstructured text is more of a headache. It's something that they can apply tools to and extract some useful information. This is not always an easy process. And some familiar tools like pandas are not really applicable to unstructured text. When you organize text into some meaningful chunks of information, meaningful nuggets of information, you end up with tokens and something that you have to discard and filter out. So you have some tokens and some garbage. Once you have those tokens, what you can do with them is apply some meaningful labels to them. Those labels can be linguistic, like in this case, POS stands for part of speech tagging and not the other meaning. But you can also have some custom tags. For example, for named entity recognition, you have tags like organizations and geopolitical entities. Once you've collected the tokens, labeled them, you can count them. But the raw count is not particularly useful for machine learning applications. You have to vectorize them. You have to transform the count into something else. And in the next step, you're going to have to weigh some tokens. Some of them are going to be more important than the others. It depends on your source material, and it depends on the information you're trying to extract from the text. Okay. That's the deep learning slide that I promised. Deep learning is a fantastic tool in machine learning, and it's very much applicable to NLP. In fact, most of the novel research, both in academia and in industry, is done using deep learning. And it's very lucrative because all you need is a huge collection of data. But you can start with something very simple. when you have no labels whatsoever, you can still take your text blobs and combine them to bigger, meaningful text blobs. This is the process known as clustering. This process doesn't require anything other than your data. It's completely unsupervised. Once you have some labels, for example, for emails you have spam and ham, the tasks become something of a classification. And there's a variety of machine learning algorithms to choose from for that. And deep learning can be done with both labeled and unlabeled data. It basically can be applied as a black box algorithm. It picks up some linguistic patterns along the way, but you don't necessarily know how it comes up with those patterns. All right. So this follows the example by Josh Wells, who introduced the data science infinite loop of sadness. I'm introducing the NLP pyramid of sadness, and it's based on how you view linguistics as a discipline. For linguists, it's a nice organized world where each level is built on top of each other and each level deals with different aspects of languages. Like, for example, phonetics and phonology deals with the sound of a human language. Morphology deals with some components of the word, like word roots and stems and suffixes and prefixes. Syntax helps combine those words into sentences. It deals with rules and constraints of how you organize words into something more meaningful as a phrase. And syntax provides help and scaffolding for meaning. Meaning is something that semantics and pragmatics deal with, and the difference is semantics is something you can look up in the dictionary, the basic meaning of the word. Pragmatics is the highest level of abstraction. It's something that's not necessarily written but understood by context. It's a world view. It's something that you understand out of the context. So, and machine learning kind of tips this pyramid and makes it a less structurally sound structure. But machine learning likes to tackle really hard problems. And in this case, it is all about the meaning. It's all about the semantics. This is where a lot of research is, and this is where the money is. For example, natural language understanding systems is where you have to combine linguistic knowledge and a lot of sophisticated machine learning algorithms, but also some rule-based stuff, heuristics. An example of NLU would be systems like Alexa. Okay. But the problem is that semantics can be really hard, and it's very language specific. Okay, I'm going back to one level down, which is syntax. If you've never done syntactic parsing before, this may be a little bit confusing. I tried to pick a more contemporary example that you don't find in usual linguistic textbooks. So I'm analyzing the phrase, this part is going to be lit. And I'll start with the verb phrase, going to be, and it has two dependency. This party, which is the subject of the sentence, and the complementary phrase, be lit. And you see, lit in this case is classified as a noun, which is not necessarily correct, but it works in the overall structure of the sentence. Those dependencies are important when you organize words into more meaningful chunks. Okay. There are some pitfalls when you're dealing with natural languages. Data produced by humans is naturally messy. You have a lot of special characters, you have typos. It's not necessarily correct English or other languages. So you have to come up with some strategies how you're going to deal with that. Even when you're dealing with correct and grammatically correct language, you still have some ambiguity that makes it difficult to process meaning. Like, for example, homonyms in English. Tear and tear are two different words that are spelled completely identically. When you look at words on the level of morphology, different word forms and noun phrases, the same word can suddenly change the meaning. Like in this example, this agreement is about a principled compromise, not a principle compromised. So just by changing some suffixes the noun phrase completely changed the meaning. And this is something to think about. Those corner cases, it's not necessarily something you'll find in your own natural language processing project, but it's something to think about before you start the processing. And it's also something important to keep in mind when you interpret the results. Okay. And it all depends on how much data you're going to have. If it's a huge collection of text, or if it's just a relatively small corpus. If you have a big data, by the law of large numbers, all the errors, all the ambiguities and special cases are going to be evened out. And a lot of time and research is invested in annotation schemas and tools to provide correct and more meaningful labels. But for the first NLP project, chances are that your data is relatively small. And then every word counts. You'll have to invest time into pre-processing. And in this case, natural language processing libraries to the rescue. You don't have to reinvent the wheel. And the library that I'm going to talk about in this talk is called spaCy. It's an open source project maintained by Matthew Honeyball and Ines Montani. The idea is to get from an unstructured text blob to something that has a lot of meaningful labels that you can use for machine learning. And it's an NLP pipeline. It starts with a tokenizer, and then you have various taggers, part of speech taggers, parsers, named entity recognition, and some custom plugins that you can combine in a way that makes sense for your task. Okay. I'm going to show some very simplistic NLP pipelines using the examples of very short sentences. And my first example, my first recipe is a tweet. In case you don't know her, Mara Everick is a data scientist, and she describes data science tools on Twitter using her own very visual language. She uses a lot of GIFs, emojis, pop culture references. And the challenge here is that it's not a lot of text. It's a lot of other characters. But what I want to see is how does an NLP pipeline deal with that? So I'm just going to read out the tweet. Star intro into a glowing star tool. Detective reg explained by @Twitter handle. And then you have a link and hashtag rstats, hashtag regex. All right. What parts of the pipeline are important? What parts are nice to have? It always starts with, first of all, the step 0 is identifying the language that you're going to deal with. In this case, it's English. This will determine what kind of language model you are using. The next step that is important is tokenization. And this is basically splitting the sentence that you have into words or phrases. The simplest case is splitting by white space or punctuation, but it doesn't always work this way. Like some languages like Japanese don't even have white space, so you have your own challenge. And in German, with long compound words, sometimes you have to split something in the middle of the word. Like the 3 English words in the phrase income tax return is Einkommensteuererklärung in German. Next step that is very important for things like organizing words in a sentence is part of speech tagging and syntactic parsing. Without it, you cannot really combine words into noun chunks. Chunking is really nice to have. Even concentrating on not 1 word, but 2 words, increasing the window size too, it improves the accuracy of any machine learning model. And it's all about the context. So as you can see in the examples, chocolate bar, bar exam, wine bar, and space bar are very different kinds of bars. And in order to understand what you are talking about, you have to look at the words surrounding your target word. All right. I will make the Jupyter Notebook available on GitHub after this talk, but I'm going to show some small parts of the code so you can see the simplistic NLP pipeline. What I'm doing here, after loading spaCy, I'm choosing the language model, in this case English, and then I'm loading the example sentence into a document object. And what I'm going to look at are different groups of tokens. In this case, a very simple divide between alpha tokens and not alpha tokens. I'm only looking at words and non-words. And then looking at noun chunks. And what I'm doing here is a very simplistic sentiment analysis. I have created a custom dictionary for emoji, and I'm using emoji count as a sentiment score. Okay, so you can see this is my very simplistic emoji dictionary that can be expanded. And the nice thing about spaCy pipelines is this is the customizable part. This is something you can expand depending on your goals. They have special containers for things like that, and you can either flag something as a token of interest, or you can create your own vocabulary list. In this case, I'm flagging it in a vocabulary list. The tokenization is done behind the scenes by spaCy. It's basically one line for token in document 1. And then all you do is use built-in attributes to filter tokens. In this case, I'm interested in words, which is alpha. And then I collect it in a list. Right. And then using the previously defined emoji dictionary for sentiment analysis, I'm just going to create a sentiment score. And the second part of it is I'm going to show you, it's a very simple example of syntactic tree dependency. And you can see I was interested in emoji and how they're integrated. Are they part of the noun phrase, or are they completely separate entities? And this example shows that they are indeed integrated. So you can see the first star is identified as a pronoun, which is not correct, but it's still part of the sentence. And I was luckier with the second emoji, the glowing star, which is part of the noun phrase, a glowing star tool. In this case, it's identified as a proper noun. But you can use that example as something, this is the prerequisite for the chunking. And my noun chunk is going to be a glowing star tool. And this is how you access the noun chunk in spaCy. Some of the noun chunks I'm not going to be particularly interested in, but this is something you can use for further filtering, if you're only interested in nouns or only in adjectives, for example. All right, so some pitfalls that you can already see with examples like tweets or social media posts. You're going to have to deal with a lot of garbage, some encoding issue. And even with emoji, they can be UTF-8 or they can be Unicode, but you have to decide what to do with them. Do you just ignore them, filter them out, or do you process them as special entities? Right. And punctuation is normally filtered out, but in case of emoji, you have to decide early on, are you going to treat emoji as a special case of punctuation, or are you just going to ignore them? And not all part of speech tags automatically identified are going to be correct. Relying on built-in models, it's something that is not necessarily a good idea. You always have to go back and double check. Like in my example, the emojis were completely misclassified. Best practices, just going through them really quickly, but please take it with a grain of salt, especially if you already have some experience with NLP. What works for my projects might not work for yours. In any case, identifying the language before any pre-processing is important. And then this decision to filter or remove special characters. Nice to have is a custom dictionary, like a vocabulary list, but it's time-consuming. Again, nice to have is chunking and noun phrases. That just makes the output and the interpretation later much, much neater. Okay. Some not to-dos is please don't assume that everything is going to be simple and well organized. Newspaper articles are on a completely different level than social media posts. If it may be very tempting to write your own tokenizer, but why reinvent the wheel when libraries like spaCy do it for you in one line of code? And just like I mentioned, don't rely on off-the-shelf, pre-built, pre-trained models. Okay. The second recipe is a Yelp review. It's a 1-star negative review, and I would like to find out why was this review negative. Is it something tangible, like the name of an employee? Maybe it's about the price, maybe it's the location. So I'm going to be interested, I'm going to be focused on very specific tokens. Okay, the text of the review. We drove 30 minutes out of our way to get some dessert and ordered a ton to go, only to find that they didn't give us what we ordered. What we did get was not good. We called and they refunded us $4. Ridiculous. Don't waste your time or money here. 6th course right around the corner is way better. I should probably mention this is the review of my favorite chocolate shop in San Francisco, so it is very surprising that it's such a negative review. All right. So what's the typical pipeline for processing something like that? It's a longer text, but it also has some challenges. What you can do with your tokens is normalize them, get them to some basic form that you can look up in a dictionary. One way to deal with it is, for example, expand contractions and expand some units of measurements, like $5. Spell it out as $5. Again, tokenization is filtering is going to be part of the process. In this case, I'm just going to remove punctuation as well as stop words. Stop words are very common words that carry no special meaning, like the and of. Those stop words are language specific, and every language has a list of those stop words. And the main part of what I'm going to do with this Yelp review is going to be named entity recognition. And like I mentioned, it's going to be something specific, like location, date, quantity, or organization. I'm going to have a lot of different tags. Right. An aside about normalization, you have two choices when you're trying to normalize words, and it's stemming or lemmatization. They both have advantages and disadvantages. Stemming is basically removing, cutting off suffixes. Sometimes it creates nonsensical words. Lemmatization is doing things properly by looking up words in a dictionary like WordNet. It produces better results and it's usually more accurate, but it can be more time consuming. So it's always the difference between precision and recall. When using spaCy, you don't get the choice. spaCy only does lemmatization. So in this case, it's going to be more by the book. Right. So this is my pipeline. I'm removing stop words and punctuation, which is again just using some built-in attributes, which is very nice, provided by spaCy. I'm not particularly interested in one specific part of speech tag, which is pronouns. So I'm just going to filter them out outright. What I am interested in is I'm tracking named entities like person, organization, geopolitical entity, and so on. And so it's just going to provide me a list of those entities. And this is the result. We can just look at what are the named entities that are identified and what was missed. 30 minutes was identified, a ton as a quantity. Money in $4, and here are the mistakes. Ridiculous was identified as a geopolitical entity. The reason being it's capitalized, and it's a single word in a sentence, so it's an easy mistake to make. Way, because of the way it was spelled, all caps, was identified as organization. So you can see this named entity is very case sensitive. This is why it produces some results that are not accurate. And there is also something that was missing. 6th course should be identified, but it wasn't. The reason for that is both parts of this named entity, 6th and course, are very common English word. And even though it's capitalized, it's not going to be identified. Okay. Just very quickly, expanding contraction, you have to be really careful. You can customize the tokenizer to include expanding contractions, but you're going to have some ambiguity with some contractions that are the same. It's very tempting to clean up the text using spell checker, but before you do that, you have to make sure that it's worth it, because the spell checker will try to correct every word in the sentence, whether it was necessary or not. And then again, lowercase is a real problem with named entity recognition. Some people don't even capitalize their own names, so it makes it very, very hard to identify. And some names, when they're not capitalized, are just very common English nouns, like a rose. Okay. So best practices is the order of operations becomes very important. Expand contractions before tokenization, spell checker before lemmatization and normalization. If you are going to convert everything to lowercase, make sure that you identify your named entities before that. And sometimes it's a very good idea to just create custom lists for named entities. It makes it more accurate. Okay, so very quickly about the last recipe, it's topic modeling. I'm not going to show a lot of pipeline code. Just what I did here, I took two texts, one translation of another, and it's a text about natural language processing with spaCy, one in English and one in Spanish. And I made those two texts a parallel corpus by splitting them into paragraphs. And by topic modeling, what I want to find out is what are the most important words in those texts. The pipeline is basically connecting everything I talked about before, including tokenization and named entity recognition. And the results are, I have identified some topics using the library called GenSim, and the pre-processing steps were done by spaCy. And I don't really speak Spanish, but I know that PLN in Spanish is the same as NLP in English. So I have some parallels already, some topics that were identified, even though the corpus was really tiny. Okay. Right. I'm gonna skip the best practices for that. It doesn't really make sense if you don't see the code. Just two words about the approaches that you can use. One is bag of word, which is basically collect all the words regardless of where they are in the sentence. The order is not important when you convert the whole document to a bag of word. And you can also have word embeddings where the context and the order of words is important. An example is doc to vec. Right. And you can think of it as Scrabble tiles. Bag of words is just the whole bag of them. And once you put them on the board and the order becomes important, then you can do more with these tiles. Okay, some takeaways for NLP projects. Don't forget that natural language is very messy and it's harder to deal with words than numbers. Looking at your input and output in any stage is very helpful. Then you can identify the mistakes. And then you can customize your NLP pipelines like I did with emoji. And just don't forget in general for natural language processing projects, domain knowledge is very important. It's better to ask the expert or a native speaker. Okay. So, like I promised, the code will be on GitHub along with the slides. So, I'm happy to answer any questions. I think we ran out of time, but I'm going to be around if you want to have some one-on-one discussions about NLP. I'll be happy about it.
Yeah, so. Test. Oh, that's great. Yeah, I hope there are many questions. We have a whole bunch of minutes for all the questions. Questions? Yes, over there.
Yeah, you mentioned
yeah, thank you for the talk. You mentioned the language that is getting chosen, so you had English and German. Is there also a split between like formal English and social media English at that position, or is it really just the high level?
The model is independent on the context, so it works for formal language and informal language. Anything you do to customize for your specific case, you'll have to do it on your own. Unfortunately, there is no social media English or Twitter English. We don't have that yet.
Over there.
Hi, thanks for the talk. I'm just a little confused about your position on chunking. That first example you had, which was star intro to glowing star tool, that's just a nominal group, right? So, I mean, it was analyzed as a clause with a verb, but it's not actually a clause. It's just a nominal group, and therefore it would just be one chunk.
It is a one chunk. It's a noun phrase.
Yeah. So what would the value of chunking be when, in your own example, the entire text would just be a single chunk?
Not exactly. The chunks would be, for example, names, first name, last name, or the whole phrase that belongs together as one concept.
Yeah.
Like United Nations would be one chunk. So the important part is you're not dealing with words as single elements, but collect all the words that belong to the same noun chunk.
But in that example, a star, like a good review for a great tool, this is a single noun phrase with embedded noun phrases.
Yes.
And because chunking's flat rather than nested, then, yeah, it just seems kind of self-defeating to apply chunking to this rather than using the dependency parse or something instead. So, yeah, I mean, you could see the tool produced a misanalysis where it said the intro was a verb, where it's actually introduction, a noun. So, yeah, I'm confused why. I don't think spaCy and Matt Honorable really recommend chunking either.
There are more sophisticated ways of produce better chunks. It becomes more important for topic modeling when you want to have meaningful noun chunks and you want to glue the words together. It's the built-in chunking may not be as useful. You're right. So when you have to customize it for the purposes of interpretation, just to make it easier to map the right chunks to the right concepts, this is something you may have to do as a customized code.
Okay. Thanks.
Thank you. More questions? Okay, over there. So I take the chance of going there. You know, this conference only works if there are volunteers. So there, you all know the signup.zone page, and you visited already, and all of you already put your name in the right slots for session chairs, video recordings, conference setup and teardown, hopefully. So you have to do it. It's not a joke. The conference will not go on if there are not enough volunteers. So here's the next question.
Yeah, thank you again. Also for introducing spaCy. I didn't know it so far. And here's also a question about how is the support for the German language for the package? So especially regarding component splitting and lemmatizing.
Sorry, I'm not sure I understood the question. Is it about lemmatization?
spaCy, the support for the German language. So, in particular for the compound word splitting and the lemmatizing. How well is that?
The language model for German is very good. So it's been tested many times. The tokenizer has been improved continually. So it's something you can find out when you run spaCy over German. I would say it's as good as English, which is really good for a language like German.
Okay,
it's not as good for, I think Finnish was the one where they really struggled. Yeah. But the compound German words, you might think it's a bigger problem, but it really isn't.
Okay, thank you.
Okay. So, more questions over there. So, as you see, the most annoying part of being a session chair is to run around. But the rest is easy. You can do it.
Thank you for your talk. It was very interesting. I just came across a library. It's called, or a package. It's called Widiger. Do you know that?
Yes.
Yeah, I just wanted to ask about your experiences with it. They're supposed to analyze also the emojis and stuff like that. How are your experiences?
Yes, so Widiger, just like Darth Vader, it's part of NLTK library nowadays. It was integrated and it's used for sentiment analysis. It's completely rule-based. It has lists of things that is like an emoji dictionary, but it's a more expanded way. It's unfortunately not very accurate. I have tested different sentiment analysis libraries, and Widiger was one of the least accurate, surprisingly. But it's that always disadvantage of rule-based versus machine learning. Even naive Bayes algorithms were more accurate than Widiger. So just to give you an idea.
Okay, more questions? No? Not at all. So then, thanks again, Anna,
Thank you.
for this great talk.